5, 4, 3, 2, 1. Hello students. Today we're going to begin a unit on probability, which is one of the parts of high school math that really does work into real life, and that some of the things you're going to learn here you will hear about at least for the rest of your life. Today we're going to deal with the idea of whether things are independently related or dependently related. For instance, here's an example of an independent relationship. The fact that I wore this particular shirt today had no bearing at all on what you chose to wear today, completely independent of each other. However, a dependent relationship would be like the type of coat or lack of coat I wear depends upon the weather outside. If it's hot, I don't need a coat. If it's cold, I do need a coat. So that's a dependent relationship. Now let's look at these couple of examples. The first one says that you flip a coin twice. The first flip lands tails up and the second flip lands heads up. All right, so does the second flip have anything to do with the first flip? And the answer is no. So these would be independent events. All right, let's take a look at number 2. A basket contains 5 apples and 8 peaches. You randomly select a piece of fruit and then return it to the basket. Then you randomly select another piece of fruit. The first piece happens to be an apple. The second piece happens to be a peach. Now, does the fact that you drew an apple the first time have anything to do with the fact that you got a peach the second time? Well, because you put it back in the basket, it does not have any bearing at all. So these would be independent of each other. However, had you kept that piece of fruit out, then the second go-around would mean that there were less to choose from, and that would have been a dependent relationship. But the correct answer here is independent. Now, in terms of mathematical probabilities, number 3, a spinner has an equal chance of landing on each of its 4 numbered regions. Alrighty. You spin twice. The first one lands in region 1. The second one also lands in region 1. So, assuming it's a fair spin, did the first spin have anything to do with the second spin? No, it did not. So the probability of the second one and the first one happening like they did, how many ways is there of spinning the number 1? 1 out of 4. Now you're going to learn that in probability and means multiply. So the first spin you got 1 out of 4, and the second spin, also white, was 1 out of 4. Now what is 1/4 times 1/4? That would be 1/16. So that would be the probability of spinning a 1 and then spinning a 1 again. And that's example 3. Alrighty, example 4, there's 6 nickels and 6 dimes in your pocket. You randomly pick a coin out of your pocket and then put it back. You return it to your pocket. Then you randomly pick another coin. Both times the coin is a nickel. So what's the probability of that happening? Well, how many ways are there of getting a nickel out of your pocket? There are 6 ways out of a total of 12 coins. So 6 out of 12. And what's the probability of it happening a second time? 6 out of 12. Now the reason that it's out of 12 is because you put it back. But if, let's just say that you put that nickel to the side, the second go around would have been 5 out of 11. And you're going to have problems like that. But this one, since you put it back, independent of each other, and so in our calculator, we shall take, well, what we've got here is we have 36 over 144. And let's see what that reduces to. 0.25 or 1/4. So that would be the probability of getting first a nickel and then second go around a nickel also. All right, number 5, a bag has 6 red marbles, 7 blue marbles. You randomly pick a marble and you return it. That's a key word before picking another marble. The first one you grab is red and the second one is blue. All right, so how many ways are there of grabbing a red marble? Well, 6 out of a total of 13 marbles. And how many ways of getting a blue marble on the second grab? Well, you've got 7 out of 13. So let's multiply these two together. And we've got 6 out of 13 times 7 out of 13. And changing that to a fraction, 42 out of 169. And that would be that probability. Alrighty, number 6. Your sock drawer has 4 white socks, 6 brown socks, 4 black socks. You randomly, you close your eyes and you pick a sock and put it on your left foot, and you pick another sock and put it on your right foot. And you leave the house with a white sock on your left foot and a brown sock on your right foot. I don't think I've ever done that, but I guess this guy did. All right, so what's the probability of getting a white sock? Well, there were how many? There were 4 out of a total of 14 socks in all. Let's see, let me double check. 6 plus 4 is 10. All right, so there was 4 ways out of 14, not 16. 4 out of 14 ways. And how many ways are there of getting a brown sock? Okay, here's where you want to be careful. You kept that white sock. You did not put it back. So in terms of brown socks, there are 6 ways left of getting a brown sock, but only 13 to pick it from. So we multiply 4 over 14 times 6 over 13. Change that back to a fraction. And you get 12 over 91. That would be the probability of doing that kind of crazy thing. All right, and the last one, we've got a bag with 3 red marbles, 3 blue marbles, another bag with 6 green marbles and 7 yellow marbles. You randomly pick 1 marble from each bag. 1 marble is blue and 1 is yellow. Okay, so the only way you can get a blue marble is going to be out of this first bag, and that's 3 out of 6. 3 ways of getting a blue marble out of 6. And we know that's 1/2. Let's see, the other marble is yellow, so that would be the second bag, 7 out of 13. And so let's see, what does that turn out to be? That'll be 3, 6, or we know that's 1/2 times 7 out of 13. And so mine is actually, well, let's see here. Yeah, 7 out of 26. And there you have it.